Dear students, welcome in video number 20 of lecture series NSEP 2022 and now I read the problem. A cyclic process 1 to 2, 2 to 3, 4 to 1 we can see in figure consisting of two isobars 2 to 3 and 4 to 1 and isocore 1 to 2, this is 1 to 2 and a process 3 to 4 represented by straight line on a PV diagram. This is a PV diagram. Involves n molecules of an ideal gas. The gas temperature at states 1, 2, 3, 4 as shown in figure are T1, T2, T3, T4 respectively. Also points 3, 4 lie on the same isotherm. The work done by gas during the cycle is. We have to determine the work done by the gas during the cycle. And we have seen that there is a process 1 to 2, that is 1 to 2 is isocore, and 2 to 3 and 1 to 4 these are isobars. And if we consider temperature at this point, pressure at this point is P1 and at this point is P2, and similarly we can consider this at this point V1 volume is V1, volume at 2 point V2, at 3 point volume is V3 and 4th point volume is V4. And now we determine the work done. Solution of this problem, in which we have to determine the total work done. And we know that in PV diagram total work done should be delta P into V, and V should be average, and delta P we can determine delta P is P2 minus P1. There is two temperatures, one is P1 at this point, and at this point this pressure is P2, so change in temperature is P2 minus P1. And if we want to determine the average volume, then we know that there is in 1 to 2 process there is no change in volume, but in 2 to 3 process change in volume is V3 minus V2, and in 1 to 4 process change in volume is V4 minus V1. So we can say we can take the average of both change in volume. It means suppose we want to determine average volume, so it should be V3 minus V2. This is one change in volume plus another change in 1,4 process V4 minus V1, another change in volume, and we can take it average. So average volume becomes V3 minus V2, just that is a change in volume in process 2 to 3, and V4 minus V1, this is change in volume in process 1 to 4 or 4 to 1, and average volume becomes V3 minus V2 plus V4 minus V1 upon 2. So work done, if we consider work done is W, then W equal to delta P means P2 minus P1, and V is V3 minus V2 plus V4 minus V1 upon 2. This is volume. And now we discuss about in process 1 to 2. 1 to 2, that is a isochoric process. Isochoric process. And in isochoric process we know that P2 T1 should be equal to P1 T2, and we require P2. Here we require P2, so P2 should be equal to P1 T2 upon T1. And similarly we have to solve for process 2 to 3. Again in 2 to 3 V3 T2 should be equal to V2 T3, and we require V3, here V3, this is V3, so V3 should be equal to V2 T3 upon T2, And we know that in 2 to 3 process V1 equal to V2, so we can write V1 T3 upon T2. Now we will take the process 1 to 4, and in 1 to 4 we can take V4 T1 equal to V1 T4. Now we require V4. This is V4. This V4. And V4 should be equal to V1 T4 upon T1. Now we can put the value of P2, V3 and V4 which we have determined. So W becomes P2 minus P1, P2 minus P1, V3 is V1. This is V1 T3 upon T2, and this V2 becomes equal to V1, so minus V1 plus V4 is V1 T4 upon T1 and minus V1 upon 2, and we have also write the value of P2, so it becomes P2 means P1 T2 upon T1 minus P1 1 upon 2, and we can take V1 in outside, then it becomes T3 upon T2 plus T4 upon T1 minus 2 and V1 in outside. And now we can take P1 in this first paragraph. P1 we can take out and V1 already out upon 2, and this paragraph becomes T2 upon T1 minus 1, T3 upon T2 plus this T4 becomes equal to T3, as in question it is given that 3 points 3 and 4 lie on the same isotherm. It means T3 is equal to T4. So we can write T4 to T3. So this T4 becomes T3 upon T1 minus 2, and now P1 V1 upon 2, we can take LCM. T1, it becomes T2 minus T1, and T3 upon T2 plus T3 upon T1 minus 2, and for ideal gas we know that P1 V1 equal to nRT1. So P1 V1 upon T1 becomes equal to nR, and this is P1 V1 upon T1. We can write it nR, and W becomes W equal to half P1 V1 upon T1 nR. Now first bracket T2 minus T1 and second bracket T3 upon T2 plus T3 upon T1 minus 2. So this is total work done in this PV diagram, and if we see the answer, then answer is half nR T2 minus T1 T3 upon T1, this C. Answer should be C. Answer of this question should be C. Answer C. So dear students, we will meet again with the next problem, and you can ask your doubt in comment box, or we have a WhatsApp group that is known as Physics Olympiad Warrior. In this WhatsApp group you can also ask your questions. This video also available with question and answer in that WhatsApp group. Thank you very much.